This is a graphic granite. What it is a intergrowth of feldspars and quartz. The feldspar is the yellowish and the quartz is the grayish. You can see that there's this regular spacing, giving it somewhat of a lamellar texture. And I've cut this rock in this way so you can see these textures much better. It's an igneous rock, and so it's formed by crystallization from a melt or magma. The first thing is to understand that it formed related to eutectic crystallization, and that's where a melt, as it cools to its freezing point, precipitates two relatively pure phases, in this case quartz and feldspar. But to get this lamellar structure, you have to go one step further. You have to have disequilibrium eutectic crystallization. And what that means is the cooling rate of this system was faster than the crystals could actually nucleate or grow. And therefore, for time being, initially you could actually have a liquid existing below its actual freezing point. Under those conditions of undercooling, you would have a supersaturated solution in both of these phases. And then eventually you will reach a threshold where you'll have very rapid nucleation followed by crystal growth. And this happens so fast that as the crystals grow, they grow faster than diffusion can homogenize the fluid. So the quartz part that grows will generate a feldspar-rich boundary layer in the melt, which then will go on to feed the growth of the feldspar. And the feldspar itself will generate a quartz-rich boundary layer, and that interaction perpetuates this growth as we go. And so it turns out the limiting factor is the spacing here. So the growth rate and the diffusion rate and the spacing are all interconnected. In theory, you can tell from the spacing of these how fast these crystals actually grow.